Hello everyone, today we're looking at Leetcode problem 1498, which is number of subsequences that satisfy given some condition. Now for this problem, we're given an integer array nums and we're given an integer value target, and we have to return the count of non-empty subsequences of the nums array such that the sum of max and min is lesser than or equal to target. Now these subsequences can be too many, so we have to return modulus 10 power 9 plus 7. So now let's think about this problem. So given an array nums, I find subsequences such that the min and max of the subsequence is lesser than or equal to target, which means I have to exclude all subsequences where the sum is greater than target, and I have to pick all the other subsequences where the target is lesser than or equal, where the sum is lesser than or equal to target. Well, this is quite a lot of search that we would have to do if we do it the brute force way. So let's try to optimize the problem a bit, make it a little bit simpler for ourselves. So the first thing that we can do is to sort the nums array. Now, what this does for us is that my nums array is now in ascending order, and so I can use two-pointer approach. Let's say this is P1 and this is P2 to get to a state where P1 plus P2 is equal to target. Now, what does this do? Let me tell you. So what we're doing here is breaking down the problem into two parts. First part is identifying a group which has the maximum possible sum. What's the maximum possible sum? Maximum possible sum that is permitted is target. And so once you have identified this group, then this is step 1 of the problem. Now the step 2 of the problem is to now find all subsequences, or let's say count all subsequences. Now since we are finding the subsequences within this group, they're all valid. I don't have to do any filters or checks or anything like that. So it's straightforward. Find the group and then count the subsequences. So 2 steps. All right. Now, what we are trying to do here is we're trying to find all possible subsequences, right, of all possible values. So starting from this, you can have sum of something, sum of like x, y, z, and then finally you get to target. So you can take all variations like this. Now since you have to find all variations like this of a group, you are fixating the first element. So the start of the group is always chosen, and rest of the elements are the ones that decide what is the overall sum that is going to be. Okay, so this is about it. This is the problem. It's quite straightforward once you get the trick of sorting and breaking the problem into 2 parts, part 1 and part 2 like this. So let's look at the pseudocode real quickly and then it'll cement up. Okay. Let's say I am, so I need 2 pointers, right? So let my 2 pointers be start and n, which is equal to len of nums minus 1. And I also need to keep a track of total subsequences, so let that be 0. So I say while start is less than n and n is less than len of nums, I'm good to go. So what do? I say if nums of start plus nums of n is lesser than or equal to target. Now I found my group. So now this is the place where I'll get to the step 2 of counting the subsequences. So before I get to the pseudocode, let's quickly think about what does calculating the subsequences mean. So if I have 3 elements, E1, E2, E3, each of them have two states. Either I take or I don't take. Okay, and so after doing this, I go to the next state from where I say take or don't take E2, take or don't take E2, from here take or don't take E3, take or don't take E3, and so on. Okay, and so these give me all of the possible variations or the subsequences, but these are all subsequences. Okay, but in this case, since I'm keeping the first one constant, if I have 3 elements, I'm going to count the all of the variations only for the second 2. Alright, so usually when you have 2 indices, start and end, the total number of elements is n minus start plus 1. But because we are keeping the first element fixed for the group that defines the group, my total can be written as 2 power end minus start, and I don't give plus 1. Alright, and so when this happens, when I was able to find a group like this, which was lesser than or equal to target, then I can move further. Okay, and so I can move my pointer one further to explore other variations, keeping p2 constant, and so that will be the second variation with this element being a constant there. Now, when will I move my p2 counter back? I move my p2 counter back when my target is greater than, when my sum is greater than target. This is when I want to reduce the sum of the group. So let's do that. So start plus equal to 1, else end minus equal to 1, and then you finally return total mod of 10 power 9 plus 7. Another thing to note, this computation we might be doing them repeatedly, so we can also have another small optimization, which is have all the possible powers that you can ever compute stored here. So the maximum power that you can ever compute is going to be of size n, so that will be my largest window. And so for I in range 1 to n, power at I is equal to power at I minus 1 into 2. So then this part can just become a lookup, power of n minus start. That's all. So that's another good optimization for us to have. Now when we come to the time complexity, most of the time is going to be taken by our sort. So I missed to write the sort here, so I would just say nums dot sort. So this is going to take n log n for me. After that, this while loop is just order of n, so the overall time complexity is going to be n log n. That's about it for this problem. Hope it made sense. I'll see you again with another problem. Thank you. Bye bye.